Good morning. So lesson 7 is has a lot to do with what we've been covering in the last couple days with graphing in vertex form, and we're going to go back to vertex form. I know we've been looking at what the standard form of the quadratic function offers, and we've learned that the c value represents the y-intercept. So here in lesson 7, what you're going to start doing is look for patterns in the axes of symmetry. You'll know when you have it, when you can find the axis of symmetry in two ways. And the two ways are going to be one from vertex form and the other from standard form and using the formula, which is your x equals a negative times b all over 2 times a. So if you can find the axis of symmetry provided vertex form or standard form, you're in good shape. So that will be the goal today. You should be able to identify the axis of symmetry from vertex form already, since we've covered that quite a bit. Now we're just kind of still venturing out to what standard form looks like. Okay, so if you guys want to pause for a minute, this is your warm-up. This is something you should be able to do from vertex form. Okay, so go ahead and pause and then come back to me. Okay, so you've paused. Now you're checking your answers, I'm sure. Without graphing, state the vertex for each of the following quadratic equations. Again, this is in vertex form. So to get the vertex, we take the opposite, which is the opposite of a negative 5 is a positive 5, comma, same. And that is a positive 3. And what this is really starting to tell you is that the opposite of a negative 5, when it happens with x, that means it's moving left to right. So this is actually going to tell you your vertex moves right 5 units, up 3. So we're going to go ahead and write those transformations down as we go. So again, the opposite of negative is positive, so it's going to go right. The vertex moves right 5 units and up 3. Okay, so I want you to start seeing the relationships, and we call these transformations. So I'm going to start talking to you about those transformations a little bit at a time. So if it's happening inside with x, it's moving left to right. If it's happening outside the parentheses in front, that means it's happening up or down. All right, so the next one. The vertex on this might look a little interesting. To show you what this would look like in vertex form, it would be x minus 0 squared minus 2.5. Okay, so with that said, x minus 0 is just x squared, so that's why it looks this way. So the vertex in this case would be at 0, negative 2.5. That means that your only transformation exists right here. So it's kind of outside the parentheses, so that means that our graph would go down from the vertex. It's going to go down 2.5, units, down 2.5. Okay, all right. And then this next one, if you would prefer, we can go ahead and put a plus 0 at the end here as a placeholder if you'd prefer. So our vertex is the opposite of a positive 4 is a negative 4, and 0 stays the same. Okay, so this would indicate that our parabola shifts left 4, and then it doesn't move up or down. So the opposite of a positive 4 again is a negative 4. So instead of thinking positive to the right, we're thinking the opposite of a positive 4, negative 4. So this is telling us our graph shifts left 4 units from the origin. All right, so hopefully you did well on your warm-up. I'm sure you did, as usual. All right, so here we go. So right now we're going to go ahead and practice writing a quadratic equation whose graph will have the given vertex. So we're going to write this in vertex form. So we're going to go y equals, in all these cases, I'm going to assume a is 1. They just want us to practice with the vertex form. So we can do that, no problem. So here we have the vertex is at the, we're not writing the vertex form. They gave it to us already. My apologies. We're going to go ahead and go y equals, a we're going to assume is 1. Now the opposite of 1.9 is a negative 1.9, and k is a negative 4. Oh boy, I'm messing up here too much. All right, take 2. All right, sorry about that. My head's just elsewhere. All right, so let's do that again. So y equals x, the opposite of a 1.9, positive, is a negative. And then we're going to write squared, and k stays the same. All right, so that's how we'd write the function in vertex form. All right, for the next one, because there's no horizontal shifting, we would just write y equals x squared, and it shifts up 100 units. This next one, y equals x, the opposite of a negative 2 is a positive 2. And then the graph shifts up 3 halves, so basically 1.5 units. So we're just going to write it as 3/2 for the sake of simplicity. All right, so there you go. There's our vertex forms based off just the given vertex. Go ahead and pause, take a minute, do what you have to do. All right, so now, instead of doing a matching game, we're actually going to go ahead and practice this. This gives us more opportunities to graph a function in vertex form and then see what it translates to in standard form. So with that, just by looking at the vertex form, you could tell that what we are given is the vertex. So vertex form, we're given the vertex, and it's going to be at opposite, same. All right, so that's your vertex. So over here, the opposite of a negative 2 is a positive 2. And the k value will stay the same. The negative 2 represents your k, h comma k. So that's going to stay a negative 2. This says that my graph will shift right to and then go down to from the origin. All right, so with that, the y-intercept, well, we would have to let x equals 0 to solve for the y-intercept. So we're going to just practice that for right now, even though we're going to have to convert this to standard form, which will give us the y-intercept. So we're going to go let x equals 0. All right, so now we're going to go ahead and simplify. 0 minus 2 is a negative 2. Whoops. Squared minus 2. And then we're going to go ahead and simplify. A negative 2 times a negative 2 is a positive 4. Minus 2. 4 minus 2 is a positive 2. So the y-intercept is at y equals 2. So we're going to prove that in just a second. So the y-intercept, when x is 0, y is 2. We're going to prove that by converting vertex form to standard form. Okay, so that was yesterday's lesson, but to prove it, let's go ahead and start by expanding the x minus 2. So it's y equals x minus 2 times x minus 2. Okay, and then there's a negative 2 at the end. So all we did is expand this part of the vertex. All right, so if you guys have picked up on the patterns with any polynomial multiplied by itself, by all means, go ahead and use that pattern. But for right now, if you see, x times x is x squared. X times a negative 2 is a negative 2x. And then a negative 2 times x is a negative 2x. Lastly, a negative 2 times a negative 2 is a negative 4. I'm going to close that up and then bring down the negative 2. Okay, and that was that negative 2. All right, so here's the thing. I now need to combine like terms. Okay, so we get y equals x squared, and then a negative 2x minus 2x is a negative 4x, and then minus 4. So for the pattern here, whenever you're multiplying a binomial times itself, you'll see that you're going to square the first term, and then a negative 2x plus a negative 2x, you double the sum. So it's a negative 2x, and a negative 2x gives you your negative 4x. And then finally, you would just square. Negative 2 squared is a positive 4. So right away, I just found out that I had an error there. LOL. We'll fix that like that. All right. So with that, we're going to bring down the negative 2. And then we combine like terms. And we get y equals x squared minus 4x. 4 minus 2 is a positive 2. And as you saw, we know that in standard form, this is your standard form now, what you get from standard form is simply the y-intercept, okay, which is a positive 2, and that's what we were able to determine early on when we let x equals 0 and plugged it into its vertex form over here. So I just want to make sure you guys understand how you can find the y-intercept in either format. All right, so now we're going to go ahead and look over here. Okay, just looking at the time, making sure we're doing well. All right, so to graph in vertex form, we know we start with the vertex, which is at 2, negative 2. The one thing I'd like to add to this component is our axis of symmetry. The axis of symmetry is at x equals a positive 2. So if you have the x value in the vertex, you have your axis of symmetry, and that's an important key feature. So let's go ahead and start with graphing this. In vertex form, we know that the vertex is at 2, negative 2. So it's got the vertex shifts right 2 and then down 2 units. Again, it goes right 2, down 2. Now that's your vertex. Now your a value, you can see that there's no a value here, so you just assume it's a positive 1. So that means I can go over 1, up 1. Okay, and likewise I can go over 1, up 1. But the run is always only 1 unit. But before I do that a value, I should tell you that the parabola does open upward since the a value is positive. So I just write a line upward to reinforce that my graph opens up. It's positive. It's happy. So now I can go ahead and do the 1 over 1 up for my a value. So my a is always going to have a run of 1, but whatever a is, in this case it's 1, so that's why we're going to go over 1, up 1 from the vertex, over 1, up 1. But at this point, you could have used your line of symmetry to do that. All right, so now we know our y-intercept is at positive 2. Here's our y-intercept at positive 2. So we're just graphing all the detailed information. So here I can count this point. There's 1, 2 units from the line of symmetry, so I can go out 2 units in the other direction and know that there's going to be a point right here as well. So here I have about 1, 2, 3, 4, 5 critical points. So that gives me enough to be able to sketch the graph of my parabola. I do just kind of look for 5 key points. Okay. All right, so there you go. I really took my time and went into this in a lot of details. So sometimes that could be a good thing, sometimes not so much. So let's go ahead and take a look at another example. Okay. So in this case, we're going to go ahead and start with just filling in the table from left to right. So we're going to go from vertex form to standard form. All right, so we're going to go ahead and start by expanding the x plus 5 squared minus 1. All right, so we get I'm just going to expand this, x plus 5, x plus 5, and then bring down the negative 1. So I'm going to begin by double distributing. Okay, so if you guys recall the shortcut, if you square the first term, that's going to give you x squared. And then if you look, x plus 5 is a positive 5x. If you double that, you're going to get 10x. So you double that value to get your bx term, and then you square the last term. 5 times 5 is 25. So this I can tell you right away is going to simplify to x squared plus 10x plus 25. And then when we subtract the 1 at the end, it'll be plus 24. But let's prove it. All right, so x times x is x squared. X times a positive 5 is a positive 5x. And then 5 times x is again a positive 5x. And then 5 times 5 is 25. And since all we're doing is adding and subtracting, I can attach that negative 1 now. All right, so pause at this point to make sure, to see if you can find the pattern. All right, so now you get x squared plus 5x plus 5x is 10x. And then 25 minus 1 is a positive 24. So if I go y equals, we now have the standard form of the quadratic equation in ax squared plus bx plus c form. And now we know, okay, so we have vertex form, we have standard form. Which is going to give us our vertex? Well, obviously, the vertex form is going to give us the vertex. So the opposite of a positive 5 is a negative 5. And negative 1 stays the same. This tells me that from the vertex, the graph is going to shift left 5, down 1 from the origin. All right, so the y-intercept, well, which gives me the y-intercept? The vertex form or the standard form? So yes, the standard form gives me my y-intercept, which is at 24. There you go. So now we have a lot of detail here to be able to graph our parabola. So I'm going to start with the vertex, which is at negative 5, negative 1. So the graph is going to shift left 1, 2, 3, 4, 5 units, and then it's going to go down 1. So doesn't leave us a lot of room. 1, 2, 3, 4, 5, down 1 is the vertex, as we saw. And then it looks like if that's the vertex, we're only going to get the arm of the graph, so it's not going to be very pretty here. So with that said, the a value in this is 1, so I'm going to go over 1, up 1 from the vertex. Also, let's draw that line of symmetry. If you have the vertex, you have your line of symmetry. Okay, so now I'm going to go back. So the a value is over 1, up 1, so here you go. And now I'm going to look for one more point. So the way I'm going to, because I don't have enough room to graph the y-intercept, so what I'm going to need to do is go ahead and find when x is negative 3 to see what the value is from one point to the right of this. I don't want to go too far on the x-axis because I might not have enough room to graph it. So I look for my outer point, and I just go 1 unit to the right, or to the left if I had the other side, and I find that it's at negative 3. So I'm going to find when x is negative 3, what is y? I could plug it into the standard form or the vertex form, but in this case, it's easier to just plug into the vertex form. So I'm plugging in again when x is 1 to negative 3. Okay, so y equals, so I'm testing f at negative 3. What is y? All right, so a negative 3 plus 5 squared minus 1. A negative 3 plus 5 is a positive 2 squared minus 1. So 2 squared is a positive 4 minus 1 leaves me with 3. So when x is a negative 3, y is a positive 3. So I'm going to go graph that point now. So when x is a negative 3, y is a positive 3. And now I can just graph. I have 3 points, so I can just go ahead and graph from there. And it's just going to be a sketch at this point. You're not going to get the other part of your parabola, which is fine. All right, so we're going to do two negatives and then call it a day. And then your homework, just to give you a heads up, um, well, actually, no, that's just going to be the part of your homework. I have one more concept to cover. So let's go ahead and look at these last two. Okay, so these last two examples are going to be, so to go from, this is going to be a little bit more work because we have a negative and a positive 3 to consider here. So to go from standard form, we're going to go ahead and just expand the x plus 1 and the x plus 1 plus 3. Okay, so the first thing I'm going to do is double distribute always. Okay, so I'm going to I expanded and now I'm double distributing. So I'm bringing down the negative, and then I get x times x is x squared. X times 1 is a positive 1x. 1 times x is a positive 1x. And then 1 times 1 is a positive 1. And I'm going to close that up and bring down the positive 3. All right, now I'm going to go ahead and combine like terms. So I bring down the negative, not worried about that yet, and I get a positive 2x plus 1 plus 3. Now, PEMDAS says to multiply before I add or subtract, so now I'm just going to distribute the negative. When I distribute the negative to the terms only within the parentheses, the signs will change to the opposite. So I get negative x squared, negative 2x minus 1. Now I could bring down the positive 3 that since I've distributed the negative to everything in the parentheses. So now I get y equals a negative x squared minus 2x, and then a negative 1 plus 3 is a positive 2. So yes, that's a lot of work going from vertex form to standard form, but it's good practice. So with that, we have our standard form. Now we need to identify the vertex. Now remember, the vertex comes from vertex form. So it's the opposite, a negative 1, positive 3. Negative 1, positive 3, just making sure I'm in the right spot. So negative 1, positive 3 is your vertex. And then what's this last one asked for? The y-intercept. So the y-intercept we get from the standard form, which is a positive 2. So the y-intercept is at 0, 2. All right, and let's go ahead and graph this. Now, because it's negative, you know our parabola is going to open downward. All right, so let's start with the vertex at 0, 2. The graph